Hello friends, welcome to Universal Technology. So today in this particular session we are going to see the problem or the numerical uh, based on the NMCP subject. Okay, that is one numerical we have chosen, that is example, find the root of transcendental equation f of x is equal to x square minus x minus 1. Okay, and this particular function is solved, that is find the root of the transcendental equation f of x by using bisection method. So this bisection method is also called as Bolzano method. Okay, and now let's start with the solution. Okay, so we have taken this particular function which is given f of x is equal to, that is x square minus x minus 1. This is the function. Okay, so initially we'll try to understand where exactly the roots are locating. Okay, by trial and error we will try to find out. Okay, we will try to put the, see here, putting the values of x is equal to 0, 1, 2, 3, 4 and so on, where in this function, that is f of x. So this function you put a 0 and get the value, put 1 and get the value, you put 2 again get the value, you put 3 again get the value, put 4 again you will get the value. Okay, so after substituting these values, you can see here it is clearly mentioned. So initially f of 0, that means this 0 has been put in this equation. So then the final answer will get minus 1. Then f of 1, will substitute f of 1. So answer is again it is minus 1. Okay, then substitute 2, then the minus the answer is 1. Okay, that means, see in this where the sign changes, so in between that your root is lying. So that means the when you take f is equal x is equal to 1, the answer is minus 1. Then f is equal to 2, the answer is 1. So therefore consecutively the output, that is the answer is, the sign of the answer is changed. That means you should understand that your roots are lies in between this 1 and 2. Okay, so therefore here it is written roots are lies between a is equal to 1 and b is equal to 2. So this is the method which we are discussing about, bisection method, or this sometimes called as a Bolzano method. Okay, for any given function. Okay, so you know that you already guessed that the where the roots are lying. Okay, you just try to understand. So here small graph has been written. This is with respect to y and x. So say this is the function. Okay, this is the curve for function f of x. Okay, and this is the root of the function. So then, so now what we got a is equal to 1 and b is equal to 2. That means these two we got. So the meaning is our this particular root is lying in between a and b. So therefore we will try to calculate the exact root, okay, by using the bisection method. So in the bisection method, so this is the table which we need to draw, because it is a simplified method. Okay, you can go with other methods also. So this is the simplified method, thereby you can able to understand properly. So this is the serial number, that is iterations. Okay, how many number of iterations we are performing. Okay, and this is the a, column A, and the column B and this is the column x. X is equal to, that is a plus b divided by 2. Okay, and then the next column is f of x. That means whatever this value is there, so that value you substitute in the function, this function. Okay, so this function, when this f of x is equal to less than 0, see clearly, when f of x is equal is less than 0, then replace a by x. Keep in mind, I will repeat once again. If f of x is less than 0, then replace a by x. Okay, replace a by x and keep b same, remain same. Okay, so likewise this is the procedure to follow. So first value, the a is equal to 1 and the b is equal to 2. Okay, so if we calculate x is equal to, it is the average 1.5 you will get. Okay, so then this 1.5 you substitute in this function f of x, that is f of 1.5 square minus 1.5 minus 1, then the answer f of x will be getting minus 0.25, and which is less than 0. Then we have replaced a with a 1.5 and b will be same. Again we need to calculate this x, then x is equal to 1.75. okay, so the answer is positive, that is 0.3125, and which is greater than 0, so therefore, so if it is greater than 0, then b is replaced with x, this x, b is replaced with x and a is kept same. Okay, and again you need to calculate x. So x is 1.625, so the f of x is 0.015625, and again which is greater than 0, then so this b is replaced with this, and again a is kept as a same thing. Okay, then the same procedure has to be followed for entire iterations. Okay, so we have performed up to 12 iterations here. You can go through this, same thing has to be followed until you can see this a and b value should get same. Okay, so then only we can able to say that the root is this particular root. So you can see 1.562 and here 1.562, that means 3-digit root, 3-digit answer we are getting it. So at iteration 12 our roots are lies at, the root is at 1.562. okay, so then see here, from the above table of calculation by using bisection method, the roots are lies between a is equal to 1 and b is equal to 2, and the root of f of x is equal to x square minus x minus 1 is 1.562. so this is the root of this particular function. Okay, so that means, so earlier a was a1 and b was 2, so now is 1 point, that means 1 point. Okay, so this is 1 point, somewhere 50 here, so 562, that means somewhere here your root is lying. Okay, so this is what your entirely the how to calculate the root of the transcendental equation of given function by using bisection method, or this can be called as a Boltzmann method. Okay, So thank you for watching.